and then you're going to do the back page on your own before lunch, and then we'll talk about the fractional exponent rule after lunch. Okay, so if you forget the property, remember you could write out your repeated multiplication. This would be x times x times x 6 times, x times x times x 8 times. What's the rule for number 1? We're multiplying. So how many x's would be strung all together being multiplied? I don't want to write them out. It is 8 plus 6. I could write them out, but it would be easier to memorize the rule. 1, 2, 3, 4, 5, 6 times 1, 2, 3, 4, 5, 6, 7, 8. This dot isn't any more significant than the dots in between these x's. So how many x's are being multiplied? X to the 14th power. I add 6 plus 8. Okay, number 2. Let's do 3 times 5 first, because those are the coefficients. What is 3 times 5? Okay, and then x to what power? Right, this guy is x to the first. So I have x to the 6th. I add my exponents. So the common mistake, do you see how 8x to the 6th could be a common mistake? Why do you think someone would come up with the number 8? Right, they're thinking about adding exponents, and then they would add the coefficients wrongly. You are multiplying these together. So if you don't want to make a mistake, you might just every time want to write out the repeated multiplication. Then you'll say 3 times 5 is 15, and I have x to the 6th. Yeah, the next one, 5 times 6 is 30 to the 6th, because 2 plus 4 is 6. Okay, on number 4, the parentheses don't matter because there's no exponent that I need to distribute. So you can think of them as I'm just straight up multiplying, like with dots in between. I like to do the order that I'm going to write the answer. So I would do 3 times 5 first. Really, you could rearrange your problem before you start. You're not really doing the distributive property. You're really just multiplying like terms in a row. So that's really what you're doing. You're not distributing the 3 to this 5. You're not distributing the 3 to this 8 cubed. You're really just multiplying like terms. So really 3 times 5 is how much? 15. Then you have what? A to the 6th. Yep, B to the 10th. And C to the 3rd. So the parentheses tend to throw people off. They only matter. Is there even one on this page that has a distributive parenthesis? This page didn't have the distributive. Okay, number 5 is the quotient rule. What am I allowed to do on number 5? Right. You technically have 2, 3, 4, 5, 6, 7, 8, 9 on top of 1, 2, 3, 4. 4 of them are gone, and you have x to the 5th left in the numerator. I want to contrast that really quick with one problem on the board. Would x to the 4th over x to the 9th be the same answer? This was x to the 9th over x to the 4th. Would x to the 4th over x to the 9th be the same answer? Think about this. This would be x to the 4th. 3, 4, 5, 6, 7, 8, 9. These guys are located where? Denominator. So you have to write your answer 1 over x to the 5th to show that it's the bigger stuff is in the denominator. So just be careful. That's a common mistake for that one. Okay, number 6. Another common mistake is people like taking the 12 and subtracting the 8. But we know that we are dividing those numbers. So how do I reduce the fraction 12/8? Students really hate fractions. We've got to get over that fear of fractions. What could I divide out of the 12 and what could I divide out of the 8 evenly? Okay, when I take 12 and divide by 4, I would have 3 left, right? And if I take the 8 and divide by 4, what would I have left? Yeah, so it's just 3 halves. 12 divided by 8 is 3 over 2 reduced. Now, N3 is going to be located in the numerator because I have more n's in the numerator than in the denominator. Two of them cancel, and I'm left with 3 over 2 n cubed. All right. What about number 7? What is 3/6 simplified as a fraction? 1/2. And think about how many m's total you have in the numerator and how many m's would cancel away from the denominator. What would you have left? You have 7, and then you have 3 on the bottom, so you'd have m to the 4th. You could write your answer as 1/2 m to the 4th or m to the 4th over 2. Means the same thing. If you like writing your coefficient as a fraction, the only way that you can't write this answer is like 1 over 2m to the 4th. You can't put that down into the denominator. So you pick how you like to write that one. What happens if there's a negative as a coefficient? You just take -8 and divide by +2. What's -8 divided by +2? -4. And then let's say I have m to the 5th over m squared would become what? Yep. And n to the 9th over n cubed would become what? Okay, you are going to go through 9 through 14. I think you should try 9 through 14, and we should check our answers before we move to the back page that has the negative property. I think 9 through 14 are good to try by yourself. I'll just give you like 2 or 3 minutes, like 30 seconds per problem or 1 minute per problem. Yeah. So how can I reduce a fraction and divide them both by the same number? So I divide 4 and I want 3 over 2. Then these two I just subtract. That's what I'm going to do. Divide the coefficient and subtract the answer. 3 is going to be the final coefficient. Because it has nothing to multiply. That is one. Yes. Did you do it on your calculator? Okay. You still divided. Oh. Negative exponent rule and our distributive rule. You don't have to know the names. I don't care if you know it's called the power rule, as long as you can figure out how to simplify the expression. I'll leave it up for just another few seconds and then maybe, or take a picture of it. Or you could take a picture at it when you go to lunch. Can I flip to the back page? Okay. These are the exact type of questions that will be on Friday's quiz. So your homework will practice it twice. We'll review it again on Friday. All right, here are a couple more properties. The distributive property. If I was to write what this means out, it would be x to the 6 4 times written out, which we know is adding 6 plus 6 plus 6 plus 6 is x to the 24th. You multiply the exponents as your shortcut, right? 6 times 4 is 24. So what would the next one be when you distribute your exponents? Do you see how your mental math skills are really helpful? Every single time you do one of these, you don't want to go on your calculator. 6 times 4. 3 times 7. Right? So you're using your mental math skills as Algebra 2 students. Okay, does anybody know 12 times 12 though? A dozen dozen? Does anybody know the special name for a dozen dozen? It's a gross. So some stores will order a gross of eggs. It means a dozen dozen. I don't know why it got the name gross. I'm sure there's an origin to it. Okay, tricky one. What is 0 times 5? 0. So what is anything to the 0 power we learned? We want it to be 0, but it messes up our pattern up here. It needs to be 1. Defined in math as anything to the 0 power is 1 because of the powers of exponent properties. Okay, number 19. What is 0 times 5? 0. So 0 times 5 is 0. So I have p to the 0, which is 1. So I distribute and multiply. Number 19. The x don't cheat the x or the y. They both get the exponent, right? Because this is really xy, xy, xy 3 times. The x gets the third power and the y gets the third power. You have to distribute it every single term. Number 20. What am I going to do to this 3? I'm going to distribute it inside the parenthesis. And what's the distributive property? You multiply, right? So I'm going to rewrite this as 2 to the 6. I'm going to rewrite this as 3 to the 12. If you do this on your calculator, it's going to be gigantic. Do you know how to multiply this on your calculator if you wanted to? 2 raised to the 6 times 3 raised to the 12th comes out to, is that 34 million? 34,012,224. It's just a number, but that's a huge number, isn't it? Whenever there's a number, I'd like you to try to write out what the answer would be. So this is equivalent, right? 2 to the 6 times 3 to the 12, I did on my calculator, is equivalent to that. I would accept, on a quiz, I mean, this is fine. So the answer would be, those are equivalent answers. Yeah, that would be a better answer if you had a calculator. Okay, number 21. Don't forget, 1/2 needs the distributive property. So this is 1/2 squared m squared. Does anybody know what half of a half is? If you have 50 cents, I take half of your money. You have a fourth, right? So you only have 1/4 m squared on this problem. Well, we simplify any numbers. So to me, this is the better answer. This is not gone far enough. 20? 34 million? Well, solving is writing the most simplified version of the answer. Some people might say this is the most simplified because this is a huge number, but last one before lunch. What would number 22 end up being? And then we'll do negative exponent review after lunch. What would be that answer for 22? B8, C24. Make sure you give that exponent every term inside so it doesn't get left out. I just wanted to look at the bottom of this sheet and talk about fractional exponents. So we haven't talked about negative exponents yet today. Well, we did before lunch actually, but not on this practice sheet. A negative exponent means it's not happy where it is. So 8 to the negative first power becomes what? We want to make the happy exponent. We just flip it and put the 8 in the denominator, and it would become 1/8. And it technically is 8 to the first power. If I don't write 8 to the first power, I would write 1/8. On 24, how would I write that one as a positive exponent? So 1 in the numerator, and then that whole thing, y to the -7, moves to the denominator and becomes a happy y to the 7th. So you flip the line and change the sign. So you're flipping up down over this line and you're changing the sign to positive 7. So on 25, you are distributing this -1, right? Both of those terms inside. So you end up with 3 to the -1 and m to the -1. So both of them have to jump over the line down into the denominator. And I really didn't have to distribute. I could have just taken this whole thing and moved the whole thing down into the denominator. On 26, if it helps for you to separate two separate terms with a times symbol, this is really 4 times c to the -3rd. Not to be confused with 4c to the -3rd, right? Because that would make them both down into the denominator. This 4 is a happy 4, right? It has a regular exponent of the first power. So the 4 is going to stay in the numerator. What is going to go into the denominator? Just a c cubed. So you'd have 4 on top. 4 is fine where it is. C cubed goes to the bottom. All right, 27. What do you think that one becomes? I have a g to the negative 2 sitting in the denominator. I need to move it, right? So technically I would have 1 times g squared in the numerator, so I would just write that as g squared. Right? G is jumped up into the numerator. 28 has 2 different negative signs. The first negative sign is just a coefficient kind of this 2x. And then this b is going to jump up into the numerator. So now I'd have negative 2x times b to the 4th. I just write negative 2x b4. What are the answers to the last 2 problems? The easiest problems on the page. Anything to the 0 power is 1. You don't even have to distribute it. All of this parenthesis is being raised to the 0 power. So this whole thing is equal to 1. Same thing here. This whole parenthesis is equal to 1. Well, that would be it has 2 squared 3 to the 4th to the first power. Right? That would be itself. Oh, because it's not xy to the first, it's xy to the 0 power. Xy to the first would be xy. What would xy be to the negative first? 1 over xy. So they each have a different meaning. Anything to the 0 power is 1. This guy to the first power is itself. This guy to the negative first power is 1 over itself. Right? These are different than what x to the 0 power is. Okay, so the last piece that I wanted to look at is the resource page. You guys are really late, pushing the envelope on late. It's 3:45, so you guys have warnings. When you get to 3, you get a write-up. So, I mean, we should be back by 19 at the latest. Okay, then let a and we weren't ready to get into this on Friday, but this is the final exponent rule that you need to know that you've probably never seen before. So up to this point, you don't have to write this down. If I told you do 4 squared, what would you tell me the answer is for 4 squared? Okay, is that the same as 4 to the 2 over 1 power? It is, right? So we've always had fractional exponents, but our denominator at this point has always been the number 1. So it hasn't caused any problems in our calculations. Now we have a denominator called n. It actually creates your favorite, a radical, as part of your problem. If it's a 2, it would be a square root. If it was a 3, it would be a cube root. X to the m is still what we're used to. It's x to the m power. So the divided by part becomes a radical. So you find the n root of the expression and you raise it to the mth power. It's a th, nth, like I'm saying the sound, like 4th, 5th. So it's like mth, like second. You wouldn't say second, the mth power, like 4th power. So this is not 12 and a half. This is not 25 times 1/2 is equal to 12.5. This is the 1/2 exponent power. We just talked, you're one of 4 that I just talked to. So the 2 is the radical, and the 25 to the first power is the number under the radical. So it's really a disguised way of saying the square root of 25. So what is the square root of 25? 5. So the 2 is coming from the denominator of the fractional exponent. I was trying to distinguish, these are 2 different problems, right? This is being multiplied by 1/2. This is being raised to the 1/2 power, something you've never seen before. Right? It's an actual operation that makes it a square root of the number. So on number 2, the 2 is the denominator, and then I have 16 cubed underneath the radical. See how the 3 is on top? Does anyone know 16 cubed off the top of their head? I don't. You know 16 times 16 times 16? But does anybody know the square root of 16 off the top of your head? No, the square root is what times what is 16? So that's 16 cubed, but I'm not ready to use that one yet. What is the square root of 16? 4. So isn't this just 4 raised to the third power? Order of operations, you can do either one first because it's coming from the same fraction. So you can change this into the square root of 16, which is 4, and then you cube the answer. And you guys know that 4 cubed is what? 64. So these you're going to do in your head without using a calculator. Okay, number 3. What's the denominator of the fraction? The 3. The denominator goes on the outside. I like to do this part first, and then I'm going to square the answer at the end. I don't know 27 squared, but I know the cube root of 27 by heart. What is 27? So this problem is just asking you what is 3 squared, and 3 squared we know is 9. So the fractional exponent rule is probably the only new one that you might never have seen before. The other ones I think are introduced in Algebra 1 and we're mastering them this week. Can I move the page? Okay, I think the very next page. Okay, so if you look at right after where we just were, see how this says more exponent practice? We're going to come back to that tomorrow and we're going to go over that page to page 405, the fractional exponent rule to work on today for some practice. But we're only going to do the front page of that one. So see how there's even more on the back page? So there's a lot of extra practice in this packet. We're just going to look at 405 for a few minutes. Everyone see 405? Okay, let's do the first couple on this page together just to get you setting them up correctly. Do you see number 1, 2, and 3 all are negative 8? Or sorry, all 8. Some of them have different negatives and parentheses. So let's see what the difference is. Number 1 is just the cube root of 8, right? 3 goes on the outside. What is the cube root of 8? So what times what is 8? 2. You can do that without a calculator. Now, the negative, you see the negative is inside a parenthesis? So that means that the negative follows the 8 underneath the radical. And can you take the square root of a negative number? Okay, but you actually are allowed to take the cube root of a negative number. So the square root of a negative number does not exist because if you tried to do 5, right, negative 5 times negative 5, that gives you positive 25, not negative 25. Why can I do an odd root? There's 3 of them. Perfect. So negative 2 times negative 2 times negative 2 gives me negative 8. So you can do odd roots of negative numbers. So the answer would just be negative 2. There's not a big difference on this problem, but the way you would set up number 3 is negative goes outside of the radical. So when there's a parenthesis, the negative follows the number inside the radical. When it's in front, remember you just save it for the end. You're going to do the cube root of 8 and save the negative for the end. So what's the cube root of 8? 2, and then I'm making my answer negative 2. I got the same answer in this problem. There's going to be problems as you go down that don't come out the same. So take a minute, try 4, 5, and 6 the way that we just did it, and we're going to talk about them in like 1 minute before you move on. So you set up 4, 5, and 6 yourself. And just so you know, the 5th root of 32 is 2. It's one that you might not have seen before, but it's easy to do in your head. 2 times 2 times 2 times 2 times 2 is 32. So you need that to answer this problem. Are they all 2? Did you keep track of where your negatives were? I think one of them you aren't. Oh yes, they all work because this is an odd root, right? So the fifth root of positive 32 is 2. This one, well, they're not all negative, was it? Okay, this one's positive 2. This one comes out. I can do it. If this had been a square root, I couldn't do it. All right, fifth root I can do -2, and this still comes out as I'm doing the negative here, but I'm still doing it on 32, so I still get -2. It did come out the same if it was a, I should have put one on here like this. This is what I thought I put on there. What if I had -16 to the 1/2 or -16 to the 1/2? Which one of these would have no solution? Which one of these two? This one you can do, because this one's the square root of 16. This one is the square root of -16 under the radical. So sometimes if it's negative under the radical, you can't do it. Okay, if you take a look at, let's do 2 more together, and then you're going to try a couple of these practices on your own. I like to do 7 together because there's 2 negatives in this problem. This negative follows 27 under the radical sign. What does this negative do? So the 3's out here, there's -1 here. What does this negative exponent do? Remember we said that's a sad exponent and it's going to move it to like the denominator at the end of the problem? So first you're going to do the cube root of -27. What is the cube root of -27? What is -27? -3, and that's being raised to the negative first power. What does the negative exponent do to your final answer? It puts it in the denominator, right? So you really have 1 over -3, which is -1/3. So that's a tricky one. Negatives are both working differently. This is a negative coefficient. This is a flipped over type exponent. Let's do the last one together, number 8. This is the square root goes on the outside, the 4 goes on the inside, and then the -3rd power we'll do at the end. So what is the square root of 4? Do one step at a time. Square root of 4 is, oh, this I always mention too. Doesn't this also mean the square root of 4? So if there's nothing written, this is called the index, we know that it's a square root. So the 2 just means square root. We usually just don't see it there, so it looks a little weird. Okay, so the square root of 4 is 2, and then what's 2 to the -3rd power? I have to do 2 cubed. What's 2 times 2 times 2? 8. But what does the negative power make my answer? 1 over 8 in the bottom. Okay, you try 9 through 18, setting them up. So remember in our pattern of things over here, we wrote this down on the other side. 2 cubed, it would be 8, but it's flipping it and putting it in the denominator at the end. Right? You believe me? Okay, you're trying 9 through 18. Set each one up. You found the wrong answer. When you're taking the 7th root of 0 to the 5th, the answer is 0 because it's a root. Right? Isn't 0 times 0 times 0 times 0 times 0 0? This is the exponent. The exponent exponent is not 0, right? It's the base that's 0. So the answer is 0 because 0 to any power is always 0. 0 times 0 is 0. The exponent of 0 makes it a 1. So there's no 1 on that problem. It's only when the exponent is 0 that you get a 1. Okay, so you're thing here. Okay, so the fourth root of 16 to the negative third would be 2 to the negative third, or 1/8. Did you get that one? That was one of the hardest ones on there, number 10. This is the square root of 16, which is 4. I don't know 4 to the 5th. Did you guys use your calculator for that one? 1024. This is the cube root of 64. So that one was easy. It should have been 4, right? Did you try them already, or are you just doing them now as I'm doing them? You tried them. Okay. Cube root I can do up to negative 5. But then negative 5 times negative 5, I would get a positive 25 at the end. 1 to any power is 1. Why is number 15 no solution? Can't take the square root of a negative number, so make sure you actually write there is no solution. Are this empty set? No solution, you could write the 0 with a line through it, no solution. 16 is pretty straightforward. Square root of 49 is just 7 without the radical symbol. Number 17 is the square root of 9, and then you're going to cube the answer at the end. What is the square root of 9? And then what's the cube? 27. And then what's the problem with number 18? Can't take the square root of a negative number, so again, that one would also be no solution. I'm just going to write empty set as my answer. And that's not on tonight's homework, but it is on Tuesday night's homework. So if you want to start chipping away at exponent properties. Do we want to play a 10-minute Kahoot? Go for it. You don't want to? Maybe you can watch and you'll get better by following along. I don't care. Sure. I have a few people that are ready to play, right? I'm shutting this.